Hi, welcome to another Maths DVD tutorial. This is the first in a series of 4 tutorials under the section called Calculus. Today's tutorial is titled Basic Principles and Differentiation. In today's tutorial, we are going to be looking at differentiation, what it is and what it can be used for. In terms of what you need to know to progress with this tutorial, you need to have a thorough grasp of the sections, functions, and algebra. We will begin this tutorial by looking at the gradient. The gradient of any graph is essentially the rate of change or the slope of the graph. Take a look at this graph. It follows the pattern y is equals to mx plus c. It has a constant rate of change, or rather a constant gradient of m. That is, its slope never changes. Now look at this graph. It is of the form y is equals to ax squared plus bx plus c. Let us look at its slope. Notice it is not a constant slope, but rather its slope is steeply negative at first, then becomes less negatively sloped till its slope is 0. It then starts to become positive. In the previous illustrations, it became evident that the slope of the graph is determined by the shape of the graph, and the shape of the graph depends on the equation determining the graph. Y is equals to 2x plus 3 has the shape y is equals to x squared minus 5x plus 6 has the shape y is equals to x cubed plus 3x squared minus 4x plus 1 has the shape In the first straight line graph, it was easy to determine the slope of the graph as it was its m value and it was constant. However, in the two graphs that followed, the slopes of the graphs were not constant but rather constantly changing. Hence, determining the gradients of those graphs were not as easy. This is where we use differentiation. The differential of any function is simply its gradient or its slope. Why do we need to determine the gradient of a graph? Remember, I said that the gradient or the slope of the graph is the same as rate of change. Let me use an example to illustrate. If we are talking about speed, we are referring to change in distance over a specific time period. For example, kilometers per hour. If we are looking at speed, we are looking at the rate of change of distance with regards to time. Hence, we are looking for the slope or the gradient of the distance versus time graph. Let us use this example. We estimate that the amount of water in a dam in a yearly cycle is as follows. This gives us the equation negative 0.2 x squared plus 2,2x plus 4 is equals to y, where y is the amount of liters in millions and x is the time period. At any point along this graph, it is easy to determine the amount of water. Example, on the 1st of March, it can be seen that there are 7.6 million liters of water. But how can we determine how fast the dam is gaining or losing water on the 1st of March? As I said before, the gradient gives us the rate of change. The gradient of the above graph is denoted by dy over dx is equals to negative 0.4x plus 2.2. That means that at the 1st of March, that's when x is equals to 2, the gradient dy over dx is equals to negative 0.4 times by 2 plus 2, 2, which is negative 0.8 plus 2, 2, which is equals to. Now, the question that should be on your mind is, how do we determine the gradient? There are two methods of determining the gradient, and I'm going to run through both of them. Method 1. First principles. When we are using first principles, I'm going to imagine that we've got a graph of the form f of x is equals to 3x plus 4. To determine the gradient, we are going to be looking for the limit of f of x plus h minus f of x over h as h tends to 0. What I mean by that is we are going to be looking for the final value, the limit of that entire expression when h moves towards 0 or when h becomes 0. F of x plus h minus f of x over h, if I plug that into our formula 3x plus 4, it becomes 3 times x plus h in brackets plus 4 minus f of x, which is 3x plus 4, all of that over h, which will become 3x plus 3h plus 4 minus 3x minus 4 divided by h. And that all happens when h tends to 0, which will give us 3h over h, which will give us 3. That is the gradient of the expression 3x plus 4. The second way of finding the gradient, and a much easier way, we could do this. Let us imagine we've got a function of the form f of x is equals to 3x squared plus 4x minus 5. The exponent by the x is going to come down and multiply by the variable, by the constant in front of the x. So that will become 3 times 2. X to the power, its exponent, minus 1. So that will become 6x to the power 1. Plus, now the same thing happens with the second term. The exponent of the x is 1. 1 times 4 is 4 times x to the power 1 minus 1, which is equals to 0. X to the power 0 is 1. 1 times 4 is 4. That means our differential is 6x plus 4. First principles usually are easy to do if we've got a straight line function or if we're working with a parabola that is x squared. The minute we've got an exponent to x greater than 2, it becomes very difficult and tedious to use first principles. Using the easy method usually works out much better, and I want you to familiarize yourself with that. I want you to have a go at the following exercise which we'll work through together. The first two I gave you to do, I wanted you to differentiate using first principles. Let us have a look at that. Number 1 read, f of x is equal to 3x plus 4. Using first principles, we can say that the gradient or the differential f dash x is equal to the limit of f of x plus h minus f of x over h as h tends to 0. All this means is that we are looking for the limit or the end amount that this will equal when h approaches 0. You'll see what this means not so much in this example but in number 2. F of x plus h will equal 3 times x plus h plus 4 minus f of x minus 3x plus 4. All of that divided by h, which is going to equal 3x plus 3h plus 4 minus 3x minus 4 over h plus 3x minus 3x plus 4 minus 4 all cancel, which leave us with 3h over h, which is simply equal to 3. That means that f dash x, or the gradient of f of x, is equal to 3. And this we know from our basic straight line sketch that our gradient in this case is equal to 3. The second one I gave you to do read g of x is equal to 4x squared plus 6x plus 8. To find the gradient or the differential g dash x, that's going to equal the limit of g of x plus h minus g of x divided by h as h tends to 0. That's going to equal 4x plus h, because it's g of x plus h, so it's plugging in an x plus h wherever there's an x. 4x plus h squared plus 6x plus h plus 8 minus 4x squared plus 6x plus 8. All of that divided by h. That's going to equal 4x squared plus 8hx plus 4h squared plus 6x plus 6h plus 8 minus 4x squared minus 6x minus 8. That's an 8. I ran out of space. Divided by h. 4 plus 4x squared minus 4x squared cancels. Plus 6x minus 6x cancels. Plus 8 minus 8 cancels. That leaves us with 8hx plus 4h squared plus 6h, all of that divided by h. That's going to equal, if I divide through by an h, that's going to be 8x plus 4h plus 6. But remember I said that h tends to 0. That means that this will equal 8x plus 4 times 0 is 0 plus 6. And that is what g dash x is equal to, or the gradient of g of x. From the third one onward, I wanted you to differentiate using any means you know how. Number 3 read y is equal to 9x squared plus 18x minus 16. Now for this one here, you could maybe use first principles, but for the next two, first principles are going to be very difficult to do. There is another technique we have of differentiating. It's a very easy way. In this case, we're looking for the dy over dx, the differential of y with respect to x. That's going to equal 2 times 9 is 18, x to the power 2 minus 1 is 1, x to the power 1 times 18 is positive 18, x to the power 1 minus 1 is 0, minus 16, remember that says if there's 16, x to the power 0, 0 times minus 16 is 0, and 0 times anything is 0, so we don't really need to put that 1 in, and x to the power 0 is the same as 1. So our answer would be 18x plus 18. If you want to simplify this further, you're welcome to. That this can become 18 multiplied by x plus 1, but that answer is what I'm really looking for. The next one I gave you to do, number 4. Number 4 read f of x is equal to 4 over square root of x plus 9 x to the power 10 minus 15 over 4 times the fourth root of x. Now what I'm going to do is I'm not going to start differentiating just yet. I'm going to take all of my x's to the top, all of the x's that are in the denominators to the top, and I'm going to get rid of all of those square root signs and the fourth root and all the rest. I'm going to get it in the simplest form to exponents, to either a negative exponent or a fraction exponent. This will become 4 multiplied by x to the power negative a half. Negative exponent because I'm taking the denominator to the top, to the exponent a half because I've got the square root of x, plus 9 times x to the power 10, that can stay as is, minus 15 over 4 multiplied by x to the power 1 over 4. Please note that this, because it's 15 over 4 multiplied by all of this, this is as if it's part of the numerator, as if it's that over 1 multiplied by 15 over 4. Alright? Now I differentiate. The differential is equal to negative a half multiplied by 4 is negative 2. Multiplied by x to the power negative a half minus 1. Instead of saying minus 1, because I've got a denominator of 2 here, I'm going to say minus 2 over 2. Remember, all of this is still the exponent. Plus 10 times 9 is 90. X to the power 10 minus 1 is 9. Minus 1 over 4 multiplied by 15 over 4 is 15 over 16. 1 over 4 times 15 over 4 multiplied by x to the power 1 over 4 minus 1, which is the same as 1 over 4 minus 4 over 4. And again, that's all part of the exponent. That's going to equal negative 2 x to the multiplied by x to the power 1 over 2, negative 1 over 2 minus 2 over 2 is going to give me minus 3 over 2 plus 90 x to the power 9 minus 15 over 4 x to the power 1 over 4 minus 4 over 4 is going to give me minus 3 over 4. That's going to equal negative exponent, so I take it to the bottom, so it'll be negative 2 over x to the power 3. It's now positive, but square root of, because it's negative 3 over 2, plus 90 x to the power 9, that can stay as is, minus 15 over, again I take the x to the bottom, 4 multiplied by x to the power 3, and I'm looking for the fourth root of that. So it's 15 over 4, fourth root of x cubed. The fifth one that I gave you to do read g of x is equal to 12x squared minus 6 over 3x to the power 4 plus 18x over x squared. Again, with this question here, I'm going to start by changing the form of this. This will stay as 12x squared minus 6 over 3 x to the power negative 4, because I've taken it out of the denominator, plus 18 x to the power negative 1, because that's 1 minus 2, which is negative 1. Now if I differentiate, this will become 24x to the power 2 minus 1, which is just 1, minus 4 times 6 over 3 is going to give me negative times a negative is positive. 6 times 4 is 24 over 3. X to the power negative 4, negative 1, which is negative 5. Plus negative 1 times 18 turns that into a negative 18. X to the power negative 1 is negative 2. That means that my differential is equal to 24x plus 24 over 3 x to the power positive 5, because I'm taking it back down, minus 18 over x to the power 2. And that is my gradient for g of x. And that brings us to the end of the first tutorial under calculus. Before progressing on to the next tutorial, I want you to go through the exercise that I've left for you in the workbook.